Hello everybody, my name is David Gutierrez and I'm in a group with Morgan and Hayley, and what we're going to be talking about are designer babies. We're going to be covering how they're made, some pros and cons, and then also some ethical issues besides that. And yeah, let's get started. Okay guys, so I'm going to be talking to you a little bit about the process that they use to stick this gene inside the embryo. And what they do is they use this the newest process is called CRISPR. It stands for clustered, regulatory, interspaced, short, palindromic, repeats. And I'll get into the process now. So here I'm going to show you how this process works in a bacteria. And so where they discovered this process was actually in a bacteria. And here I have crudely drawn out for you a bacteria, this little potato-looking structure, with a bacteriophage. And let's just draw its DNA right here really quick. Okay. And so what happens is when a virus infects bacteria, it'll insert its DNA, which is that little squiggly line right there. It'll insert that DNA, and what that DNA will do is it'll take over the cell and it'll make a bunch of copies of the virus. Now this happens to most of them, and most of the bacteria will die. But if they don't die, what the bacteria will do is that, kind of like the same way your immune system works with antibodies. If you get sick, then your body will produce antibodies, so then you won't get sick as long. Same thing with the bacteria. What they do is they take a little piece of that viral genome and they incorporate it into their own genome. And they start storing this. So if we were to draw this, what color should we do? Try and draw this. So if we were right there. So if this was a little piece of the bacterial genome, and we had, let's say that color's purple, a little plum. So we take this little genome right there, and we're going to insert it right in there because this was a very lucky bacterial cell and it lived. And so as this bacteria lives and it experiences, after it fights a lot of different viruses, you could say, it'll keep collecting these little viral genomes and incorporate them into its DNA. And what follows it is this little part right here, and this is called the CRISPR repeat. And it's called CRISPR repeat because there are several different copies of it. And so let's say that this bacteria has a lot of bad luck and it gets infected again by the same virus. And so what happens is that the virus once again inserts its genome, insert that big old strand of, what can I make this? It'll insert that strand of viral DNA. And so this cell is smart. And so what the bacteria will do is that it'll create this cRNA right here. And that cRNA then joins forces with this TR. It looks like tracer RNA, but it's but what it is transactivating CRISPR RNA. And so what these two will do is that they'll find this enzyme called Cas9. And what Cas9 stands for is CRISPR associated system 9. So what they'll do is that they'll find a portion on this virus DNA, and what Cas9 does is it'll snip it. It'll snip it right at, it'll make a double-stranded break. And so what's hopefully going to happen, the reason this actually saves the bacteria, is because hopefully what the bacteria has is a whole bunch of these little pieces that it saved from the last time that the virus infected it. And so it'll attach all over on that virus DNA, and it'll just chop it up. And if it chops it up, then it can't affect anything. So what I'll do is for the genetic material of an embryo, it'll snip that DNA, and what scientists do is that they'll insert a plasmid with either a plasmid or they'll insert a retrovirus. And what that does is it'll be complementary to the embryonic DNA. And then from there, it'll get incorporated, and then hopefully it'll express that trait. Or they can even go the other way with the CRISPR system, and they can use that cutting to silence a gene. So if there's I don't know if there's a certain disease they could use that to hopefully stop it and from expressing. Okay, guys, and so that's just a little bit of the process of how these designer babies are made. Here's a list of my sources that I used for this portion of the video. And thanks.
Alright, I'm going to talk about the pros and cons of designer babies. I'm going to go through some of the pros first. When modifying the baby, the embryo is scanned for any defects that it might have. It is also scanned for any specific genetic diseases. Some of these specific genetic diseases are Down syndrome, Huntington's disease, and Alzheimer's disease. These are just some examples, but there are many other diseases that can be identified. If the embryo has any of these defects or genetic diseases, the embryo can be terminated. This allows parents to give the baby genes that they do not have. So if they carry a genetic disease, then if they genetically modify their baby, they can make sure that that baby doesn't have that disease. It also reduces stress and financial strain of parents. So I know a lot of financial and stress comes with having a baby with a disease or a defect. So eliminating this really helps the future parent. Another pro is longer life. By being able to scan the embryo and preventing disease and defect, this decreases the death rate and increases the lifespan. So another pro is that you can choose the sex of your baby. I read in a lot of articles that a lot of people find this as a pro. I'm not really sure why. I guess it's a big deal to a lot of people. To me, I'd rather have the element of surprise, I guess. And then according to Stephen Baird, the majority of techniques available are only being used for the people who need help with fertility to have children. I think this is important. I think it should be used to help the people that need help to have children. Alright, some of the cons is termination of embryos. Examples of that is accidental termination and when you terminate when the baby has defects and disease. And since they screen the embryo, if they find that there's anything wrong with the embryo, they will terminate it. And a lot of the procedures, they may accidentally terminate the embryo, so that's kind of scary. Another con is safety, and this is basically fear of the unknown. So what I read in the articles is that we basically don't know a lot about the long-term safety effects for the genetically modified baby. So it's kind of a gray area, and a lot of people are really iffy about what will happen in the future. Another con is designing babies based on appearance, height, weight, and intelligence. So basically their looks and their smarts. They're really worried that people will start just wanting to genetically modify their babies to get the best looking child or the most intelligent child instead of actually using it for diseases and defects in that. And then this will cause individuality to decrease. So when people start seeking out genetically modified children for looks and intelligence, basically everybody would become cookie cutter, I guess, and you would see less differences and more similarities between people. So the main thing is it morally wrong? I read in a lot of articles that this is a big debate and a big con, especially in Oklahoma. I know a lot of people are pro-life, so the termination of embryos would really be a con. And then, are we playing God? Are we trying to do too much and instead of just letting things happen and take its course? So these are my works cited, and I hope you enjoyed my pros and cons.
Hey everybody, I'm going to be discussing the ethical concerns of designer babies or test tube babies. First, I want to tell you a little story that I read. The Smiths are a couple. They are 29 years old. They have one daughter who was born naturally, and they are hoping to have 4 other children. Mrs. Smith, being a current events fanatic, decided to read the local publication about the Human Fertilization and Embryology Authority, and how they were allowing a embryo to be tissue tested and be born to help an older sibling who had a terminal disease. Now, Mrs. Smith started thinking about it, and she thought, well, if it's good to do that with a second child after the first child has been diagnosed with something, why not do that with all of your children before any of the children are diagnosed with a terminal disease? That way, you wouldn't be able to say that the second child was only brought along as a donor baby, like a spare parts baby, or anything like that. It would be considered socially responsible for the children to be matched as donors from the beginning. And that way, if one of the kids did get sick, they automatically had, in case, 4 other donors that would be available. Prevention is better than a cure. Otherwise, why would they tell us not to smoke cigarettes if it weren't damaging to the body? In addition, it is considered morally sound, and they would be providing better health security. However, the FEEA requires special permission for the parents to allow this to happen, and it must be a last resort, and the child, like if you're wanting your second-born child to be tissue typed, then the first child must be terminally ill. Now the question is, why not allow this to happen? Why not let it prevent less severe cases? After all, the moral constraint already exists. If a sibling or a parent matches and they can donate, say, a lobe of the liver, the family is already going to be morally obligated, in a sense, to donate for the family member. However, this isn't considered to be related to the basic healthcare needs. Also, there is no really medical indication to justify this. However, the definition for medical indication requires that an individual undergoing a diagnostic or therapeutic procedure has a condition that calls for medical help. So that means that neither the mother undergoing IVF, which is in vitro fertilization, or the child, which is subjected to PGD, which is pre-implantation genetic diagnosis, would qualify under this. However, on that strict of a definition, immunizations, live donations, and ultrasound-assisted liposuctions could not be offered. Fortunately, we use a broader definition that would be virtually impossible to deny the Smiths the right to do this. Now, the next big issue with this would be the creation and destruction of early human life. The Catholics believe that human life begins at conception. However, not everyone believes as the Catholics do. This causes issues with that. In addition to, a theologist who tried very strictly to keep religion out of it said that human beings are ends in themselves. They must never be treated as a mere means to someone else's ends. Allowing the Smiths to select embryos which could one day serve as a stem cell donor for one of their siblings would clearly violate the moral respect that is owed to each and every human being. Personally, I think it is a fine line that we're treading here trying to get this done. I think that morally, people will have a large disagreement with this. However, I don't think we should try and stop science with this. Here are my sources, and I hope you enjoyed.
All right. Thank you, Hayley and Morgan. And so I hope you guys are a little bit more informed about how the babies were made and a couple of the issues on both sides. And hopefully we'll see some more of this later, or maybe not. Thank you.